Hello, I'm Mike Beckett with MD Alignment Services. We're going to make a series of videos on tire wear and handling issues on medium and heavy duty trucks. The information contained in it is going to be basically my opinion and my experience and the experience of our customers that have fed back to us. You're free to agree or disagree with this as it goes along, but these will be my opinions and we'll list what we think works. I hope you enjoy. All right, I've got one for you today.
You got one for me?
Yep, I got one for you. Fella called up, talked to him. He can't understand why he's had his truck aligned 3 times. They give him printouts that say he's within factory spec, but he still has handling and tire wear problems.
That sounds like a heck of a mess.
It is a heck of a mess. Let's start.
Possible.
No, it's possible.
He's wrong.
No. He's right.
He must have done something to his truck.
No. Let's discuss where factory specs came from.
Okay.
I'm a member of the Maintenance Council of American Trucking Association, and from '97 until 2000, we had a group come together to help write an RP, a recommended practice, on the alignment of trucks, because everybody had an opinion on what is and what isn't right about it. And in this group, we had the truck manufacturers, the tire manufacturers, the axle manufacturers, and the alignment equipment companies, all of them in there arguing about what is and what is not alignment. After sitting and discussing it for a couple of years, it became perfectly obvious to me that everybody had a different point of view. So let's look at the factory's point of view that builds a truck. Before we get into describing how these alignment specifications came about, let's start and show you the specs we accumulated when the TMC group was doing its work. We accumulated alignment specs from truck OEs, alignment equipment OEs, and more truck OEs, as you can see on this first page. And the first column indicates the source these came from. The second column talks about the toe specifications each one of them gave us, and they don't all match each other. The third column is the camber, and depending on which axle was specified for that vehicle, there are some changes in the camber and the tolerances left and right. But the alignment equipment company only has one spec, and it assumes everybody's going to match that. The caster in the fourth column, and then the thrust in the fifth column, which is the alignment of the drive axle relative to the frame. And the last column is the scrub angle, which is how closely aligned the 2 drive axles are to each other. Then if you go to the second page, we have a tire OE, another truck, another tire, another truck, and then at the bottom of the page we get to the axle manufacturers. And again, you have the toe in, the camber, the caster, and thrust and scrub. As we looked at all of these, we realized that if you took one truck and its recommended settings, and one tire, and one axle, and put it on an alignment machine, you wound up with 4 completely different sets of specs. And now we got to decide which one's right and which one's wrong. It became very complicated to determine what was the appropriate spec for a vehicle. And we took these and we put them on a graph to make it a little more obvious. The first graph I'm showing you here is the toe-in graph. The red dots in the middle indicate the preferred alignment settings based on whether it was a truck or an axle manufacturer. And on the left-hand side, the 0.06 would be about a 16th toed in. The 0.02 would be less than a 32nd toed in. The green dots at the bottom indicate the maximum toward toe out that would be accepted, and some of these actually went to toe out. The blue dots indicate the amount toward toe in that would be acceptable, and some of them were pretty significant amounts. The next page are the thrust measurement specifications. This is the alignment of the drive axle to the frame. And you'll notice the vast majority of them are right on the 0 line. But the available range goes quite a ways left or quite a ways right on some of them. And the last page is the scrub angle, the alignment of how closely the two drive axles should be aligned to each other. And again, 0 was the dominant number, but the range on either side of 0 was uniformly very wide, which affects tire wear and handling. Now that you see the specs we got when we pulled it together, we'll continue with the story about where these actually came from. I'm going to use a mythical truck company, Brand X. And at Brand X Truck Company, they have an engineering department. And in this engineering department, there is a chassis engineer. And he's using books that tell him how to build trucks, and he's using documents that were produced by his predecessor on what the suggested alignment should be.
Smart feller.
He is. In reviewing all of this information, determined that the best way to align a drive axle, and that's all I'm going to talk about for right now, is alignment of a drive axle. That the axle should in fact be centered side to side under the truck, and it should be aimed the same direction as the frame's going.
Makes sense.
Perfect. Center it, aim it straight, we're good to go.
Why wouldn't you?
Why wouldn't you? He calls in the industrial engineer who runs the manufacturing plant. And he says, I want you to build the chassis, and I want you to have the axles centered, and I want you to aim them dead straight ahead. So 0, 0 is the specification we're going to use. The industrial engineer says, are you out of your cotton picking mind? I cannot build 250 trucks a day and have every one of them perfect 0, 0.
Well, he can. He can. But then the whole world has to change.
Well, no, he can't. Because he can't build 250 trucks a day to that spec.
He could have 250 alignment techs.
No, it's just not practical. Can't do it.
See, it becomes completely
Impractical.
ridiculous
Right.
to pull this off.
No, it won't work. So he tells the engineer, you've got to give me a little tolerance on what these settings can be. And the engineer says, well, how much tolerance do you need? I don't know. Let's go down to the assembly line floor and we'll talk to George and Fred, who've been doing the alignments down there for years.
2 guys. They don't have 250 guys. They got 2 to do
2
250
guys.
trucks.
Right. Well, they've got
On day
assistants.
shift.
They've got assistants, too.
Okay.
But these 2 guys are experienced fellas.
Okay.
So they could talk to them and they said, how close can you get this to 0? Well, given the alignment equipment you guys provide us, and every plant uses something a little different, and every few years they tend to buy something different that's newer and better. But given the stuff we're using right now, and given that I have to align 2 drive axles on a truck as it comes down the assembly line, and you give me 7.5 to 9 minutes to align 2 drive axles,
Based on the number of trucks you need to do.
I can get them within these 2 numbers.
These two almost
Whatever
arbitrary numbers.
whatever these 2 numbers are, I can get them within these 2 numbers. And they said, well, I guess that's our spec then. So then they went to the warranty manager. And they told the warranty manager, we're going to use this as a preferred spec, 0.
0.
And we're going to use these 2 numbers as the allowable tolerance.
Allowable tolerance.
And that's what we're going to put out here as our recommended spec. Now the warranty manager says, where did you get these 2 numbers from? They said, well, we got them from Fred and George.
Fred and George, because Fred and George know what's going on.
They're our guys. They said, no, that won't work. Well, why not? Because Fred and George aren't always here.
No.
They can be on vacation. They can be sick. And when they're gone, Tim and Sam are in there.
Tim and Sam work Fridays.
And they don't do quite so good as Fred and George. So you have to move those numbers out just a little bit more because as warranty manager, it's my job to not pay for anything.
Really?
Right.
It's almost like an insurance rep.
Correct.
He doesn't pay for things.
Yes, we take your money, but we don't want to give you anything.
That's the idea.
So, we now have a new spec that says preferred here, allowable tolerance out here, and if the truck's within those numbers, not only get it out the door, but if it goes to an alignment shop and it's within those numbers, we're not going to pay for it.
There you go.
Because they don't guarantee that the truck will drive right or wear tires right.
They guarantee that it will carry a certain load a certain distance for a certain number of miles.
And that's it.
That's the real concern.
Okay. Now, having all of that information, as an alignment guy, I found that if I used factory spec and stayed within their numbers, I could give you a printout and say it's not my problem anymore.
Yeah. Yeah, isn't that great?
But it doesn't solve your tire wear problem.
So?
Well, if you want repeat business, it's good to solve the problem.
Now, apparently, it doesn't matter.
It doesn't matter to somebody.
Some people seem to be able to get plenty of repeat business by saying it's at the factory spec.
And it must be your tires.
Or you did something to the truck.
Or you're driving too fast.
Right.
Right.
So the question is,
what numbers do work?
what should we be doing?
The factory's numbers are designed to build 250 trucks a day. They're not designed to get optimum tire wear. If I was doing 250 alignments a day, I'd use the same spec.
Yeah.
But we, over the years, have found specs that work better at producing the kind of tire wear we want. In the drive axle alignment section, we'll go through how we set drive axles and why. In the toe section, we'll go over how we worry about toe. And all of the other different ones will show you all the different stuff.
Now, what kind of an improvement can we expect?
Well,
Just to take you a little off course here, do we have any experience on taking things that were done at factory spec and putting them into our spec
Yes.
and seeing an improvement?
yes.
Really?
The average truck today, using conventional alignment process and factory specs in a line hole application with a premium steer tire, is averaging somewhere between 80 and 100,000 miles on steers.
Well, that sounds great, doesn't it?
No. Because the average truck aligned using our tolerances and our procedure with a premium steer tire and line haul is averaging somewhere between 160 and 180,000.
That's a little better.
A little better. It tends to save a lot of money. The truck handles better, it drives better, the tires wear better, and a guy can make a living at it. That's not the best. We've got people that get better mileage than that, but that's the typical steer
Right,
tire
okay.
life.
But in order to pull that off, do we have to align that thing every 50,000 miles?
No.
And
No.
thereby eliminate the improvement in cost you just got?
No, our experience with trucks is there's two types of alignments. There is a break-in alignment. You take a brand new truck with brand new components, cross members, bushings, springs, everything new, and align it brand new when it goes into service. And during the first 60 days to 30,000 miles, that truck will settle in. And you need to do a break-in alignment at about the 60-day period. After the break-in period is over, the typical line haul truck, now I'm specifying line haul because it's a certain amount of abuse that the vehicle's going to get. The typical line haul truck is going to need a slight realignment about every 200 to 250,000 miles.
Or when something breaks,
Or gets bent
gets worn.
or worn.
Right.
And you can identify that by watching your tire wear and paying attention to handling when a problem's going to start coming up. Long before you ruin a tire, you can see the indications early on.
Fleet operations have it made in this regard because they can put together PMs for all their trucks.
Well, owner-operators can too because they're right there watching their tires all the time. You've got every opportunity to know what's going on.
We can teach you all that.
Yep. And we're going to work on it in the rest of these videos. Thank you.